Hi class, we're on our second video lesson for our second section of chapter 7. What you just watched was finding zeros of a polynomial function. Now what we're going to be doing is we're going to be finding relative maximums and relative minimums. So I'm sure you've heard of maximum and minimums before. In chapter 6 we talked about parabolas. Parabola shaped like this parabola has a minimum value. This parabola right here has a maximum value. So that's an absolute minimum and an absolute maximum. With polynomial functions, we don't have absolutes. We have relative minimums and relative maximums. The reason for that is that our polynomial functions look a little bit more like this. So our minimum value, this goes down to negative infinity. Our maximum value, this goes up to positive infinity. So we can't say where our maximum value is because it goes all the way to infinity. So our relative maximum is a new term that we're going to talk about right now. It is the highest point besides infinity. So looking at this one, it's the maximum point for cubic functions besides infinity. That's our first star right here. Our second star is it's a turning point. So think of it as like a hill or a mountain. It's that top point besides infinity. There can be one, there could be more than one, or there doesn't have to be any at all. There could be none. So for this particular one, our hill is right here. This is going to be our relative minimum point where that green dot is right there. That would be our relative maximum point. Our minimum point is obviously the exact opposite. It's the lowest point besides infinity. So our relative minimum in this case would be that valley there, that little, decrease as we go down. It is also, again, a turning point. So these relative maximum and relative minimums, they're turning points. Once again, there can be one, there can be more than one, or there can be zero or none at all. So this point right here would be our relative minimum. And this is our relative maximum. Hopefully that makes sense. Like this one says right here and this one, we can have a polynomial function that might look something like this. Well, now class, where is our relative maximum at? Our highest point or our hills are right there and right there. So in this one, there are two relative maximums. That's where this third bullet point comes in, where there can be one, more than one, or none. In the same way, where are our relative minimums at? There's one right there, and there's one right there. It's those valleys. So think of the maximums as being those peaks, and the minimums as being those valleys. And we're going to calculate those using our graphing calculator. So once again, take out your graphing calculator, and let's put this function in there. Y equals x cubed minus 5x squared plus 3x plus 2. So once again, go to your y equals, and let's put in our function, x raised to the third power, or x cubed. You're going to subtract 5x squared, add 3x, and add 2. And now we're going to graph this one. So what our goal is here, going back to our directions, let's find the relative maximum first, and then let's find the relative minimum. So first, finding our relative maximums. Here's our function, our hills. How many are there? There is one right here, and that's all I see. So there's only going to be one relative maximum. So here's how you find that one, class. First of all, you can kind of approximate. It looks like it's right at around 0 and up at a positive 2 or so. So you can kind of approximate, but we do need these to be exactly precise and accurate. So the way we do that is, you guys saw this button on our first video to calculate a 0. Once again, we're going to use that button. So you're going to go to second calc or second trace to get our calculate. There's our menu. In this case, we're going to go down to number 4 because we want to calculate a maximum value. So you're going to press enter right here. In the same way, it's going to ask for a left bound, a right bound, and a guess. So you're going to go to the left side of that peak. So find where your cursor is. As you can see, mine is right here. Find where yours is and get to the left side of that hill. get to the left side of that maximum. So right about there should be good. I'm going to press enter. Now it's going to ask, my calculator is going to ask me, go to the right side of that hill. Go to the right side of that maximum. So I'm going to continue to scroll right. There's my cursor. I'm going to press enter right there. And now finally it says guess. So let's put our cursor as close as we can right on top of that maximum point. Press enter. And in this one class, we need an ordered pair. So our XY ordered pair is 0.33, rounding to the nearest hundredth, and at 2.48. 0.33 right here, and 2.48 right there. So let's write that in an ordered pair, and be sure that you label. This is our relative maximum. I'm fine if you write it like this, is going to be at 0.33, comma, and at 2.48. So that's how I want you to write it. If you look at this one, there could be one relative maximum, 0, or more than one, and as we already talked about, there's just one of them, so we're done for our relative maximums. How many relative minimums are there? Once again, there's just one valley, so we're only going to have one relative minimum point. We're going to find that the exact same way as we did the zeros and the exact same way we found our maximum. You're going to go to second trace again, which is to calculate. This time we're not calculating a 0, we're not calculating a maximum, we're calculating a minimum. So go down to number 3. Press enter at this point. In the same way, let's go left bound, and right on top of it. So scrolling down to the right, I am on my left bound, so I'm going to press enter right there where my cursor is. Now it asks for right bound, so continue to scroll to the right. I'm going to press enter right about there. And then it says guess, so I'm going to put my cursor right on top of it, as close as I can. And there's my other one. So my minimum value is at 2.99, which is so close to 3, we'll call it 3, and at -7. 3, -7 is where I have my relative minimum. So that's how we're going to define it. Relative minimum is at, what did I say? 3, -7. And this is all I require for you on number 1. So hopefully nothing too difficult. We're using a lot of the same processes that we used on our zeros and on our relative maximum and minimums. So why don't you guys try number 2, pause the video, try to get all of these ones on your own, and then you can check your work with mine after you're done. Unpausing the video, you should have gotten one maximum value, your maximum, the relative maximum, you should have gotten to be at 0.07 and at 5.04. So there is your relative maximum point. You should have had 2 relative minimum points. There are 2 valleys on this one. So make sure you label both of those. That's a terrible color. Relative minimums. Your first one is going to be at -1.91. And that y value is at a -9.14. Your other relative minimum point, because there are 2 of them like I said, is going to be at 1.83 and at a -5.4. Hopefully that makes sense for number 2. If you got these answers, you can stop watching the video, and we're going to get our assignments coming up here when you get to class tomorrow. On a worksheet, we're going to be doing this exact same thing, finding relative maximum, relative minimums, and our zeros. If you did not get these 3 answers, I am going to go through those right now so you can continue watching the video, and maybe you can see where your error was. But if you got these, feel free to turn the video off and relax for the rest of the night. All right, proceeding. We're going to put this into our graphing calculator. X to the 4th minus 7x squared plus an x plus 5. So we're going to go to y equals, clear whatever you had in there, and it is x raised to the 4th subtracting 7x squared. Then we're going to add an x. And lastly, add 5. And now we're going to graph. As you can see here, oh, whoopsie, I must have pressed the wrong button in my calculator. Let me see this again here. Y equals, I should have x raised to the 4th power minus 7x, oh, that's where my error was. This 2 should be raised to the 2nd power. Alright, sorry about that, class. Let me start all over again here. Alright, x raised to the 4th minus 7x squared minus 7x squared plus an x plus 5. Let's see if this works out better for us. There we are. Hopefully your calculator sees something like that. So just as the answer stated earlier, there is one relative maximum, it's right there, and there are 2 relative minimums, right here and right here. So let's find the relative maximum first. So you're going to go to second trace, which is the calculate button. We're going to go down to number 4 because we're going to calculate a maximum. Let's go to the left bound of that maximum, so right about there. And now let's go to the right bound of that maximum. There should be good. And now let's try to go right on top of that hill. And so our point, 0.07 and 5.04. 0.07 and 5.04. Which is how I got this point right here. 0.07 and 5.04. So now let's find our 2 relative minimums. Second calc once again, or second trace, which is the calc button. Now we're going to find our minimum, which is number 3. So scroll left as far as you can to get to the left side of that hill, right about there. Now let's go to the right bound of my minimum, right there. And now I'll try to put your cursor right on top of it. Right there should be good. And it says that my minimum is at a negative 1.91 and a negative 9.14. And that's how I got this negative 1.91, negative 9.14. And the last one, there are 2 relative minimums in this one, so make sure you tell me what they both are. Second trace once again, going down to number 3, we're calculating a minimum. Let's scroll to the right. Right there is our minimum value, so we're going to go to the left of it. Our cursor could be right about there. Now it's going to ask for a right bound. Right there should be good. And now let's try to put our cursor as close as we can to right on top of it. And now our third. Is it thinking? What's happening? Second, calc. I don't know what's going on here. Number 3. There's my left bound. Now I will go right bound. Put my cursor right on top of it. There we are. 1.83 and a negative 5.39 or negative 5.40. And so that's how I got my third point. Positive 1.83, negative 5.4. So that's going to be our assignment when you get to class tomorrow, is to find those 3 things: your zeros, your relative maximum, and your relative minimums. Be sure to ask me questions if you have them, as far as maybe pressing the right button on your calculator, in what order, whatever the case might be. And make sure you recognize that if you have a strange looking graph, you know, it could have all these humps and valleys and peaks and whatever the case might be, you got to be able to recognize where your relative maximums and where your relative minimums are. Here you have 1, 2, 3 maximum, and that's okay. Here you have 2 minimums, and that's okay. Wherever you have a hill, there you have a maximum. Wherever you have a valley, there you have a minimum. So like I said earlier, you're going to get a worksheet on that tomorrow. Make sure you bring your graphing calculator. You can't do the worksheet without your graphing calculator.